Hi everybody, can you hear me? I'll try to speak into the microphone here. So my name is Lidström. I'll be talking about the trends in open optical networks and a little bit about embedded optics and what's happening over there and the challenges around that. Before I start to dig into the technology, I'll give a quick and brief introduction to who we are. Do I change slides somehow? Or? Ah. That helps. So Smartoptics is a Scandinavian company with two major offices in Stockholm, Sweden and Oslo, Norway. We do have sales offices in UK, so Paul and Max are the sales reps here, in US and Germany. But the majority of the sales that we do is coming through partners. And one of the reasons why we have a lot of partners with a very strong global presence is that we have, since we started, been heavily engaged in the optical industry and optical sales with fiber channel primarily. So we are certified with fiber channel optics both for Brocade and Cisco, and through that we get a lot of partner activities and a strong partner relationship. But we are also focusing and doing a lot in regard to open line system, and we are in the process of developing open ROADMs as well. So that's the main topic that I will discuss around here today. So if we look on the trends in open optical networks, it's one of the strong trends that you see today is around disaggregation. So before I start to go through a little bit about it, I'll just give you a brief introduction on what I think is a pretty good explanation of what disaggregation is all about. If we take the left side there, that's a traditional way of deploying optical network gears in networks today, where you have a large chassis. In that chassis, you plug in slot-in units with dedicated features. Those slot-in units are manufactured from the same vendor as the chassis. It could be a slot-in unit with the functionality of a ROADM. It could be a transponder. All those boxes are then controlled and managed through a vendor proprietary network system. They are talking from that network system through proprietary interfaces, and the data models are proprietary within the boxes. If we then compare that to a disaggregated approach, then you take separate the functionality of the hardware and make dedicated boxes for each functionality. So in this case, there are pizza boxes. One pizza box could have the functionality of a ROADM. The other one could have the functionality of a transponder or an amplifier. Those boxes can come from different vendors. They are controlled, however, through a common and open standardized network controller. They are also talking through open interfaces that are standardized. It could be netconf, for example. And the data models to represent the functionality of the boxes are done in a standardized way, for example, through Young models. So that's, for me, a pretty good picture of what disaggregation is. So why do we see this trend? Why was that even happening from the beginning? It was heavily driven by the big cloud providers, Google, Facebook, Microsoft, and so on. And what you want to achieve, if you do this correctly, is some of those highlights that I point out there. You want to be able to take advantage of faster innovation. So by separating hardware and software, you can get a new hardware that's not correlated with the software feature that box has. You can also do cost saving both on OpEx and CapEx. So if you can now buy the best of breed online system, for example, from one vendor, you can get the best both technology and price from that regard, and then you can go and shop your transponders or whatever other optical components you want from another vendor, and then get the best of breed from that in that regard as well. It also gives you the flexibility of selecting vendors, so you don't get into the vendor lock-in situation where you are locked in and have to wait for that specific vendor to come out with a certain software feature or a certain hardware feature on a new blade. And if you do this correctly, it's also supposed to be simplified. So that means if you have a common and open controller, you should be able to plug in a new unit and it should be able to come up by itself. All of those things sounds really good, but there are, of course, a lot of challenges to achieve this in full. So if we look at some of the different levels of disaggregation, so if you talk to someone, what is disaggregation for you, it will mean different things. But if I've done a couple of examples of the type of disaggregation that we see here today on the market. The first one is something that is fairly commonly deployed today, where you use one vendor's controller, for example, for an open line system. You control that through a higher hierarchy controller that can also control, for example, transponder from a different vendors. So this is a fairly well-deployed model for network today. But you can also take that one step further and separate the hardware and the controller completely. So each individual box will talk directly up to a controller, and that controller will build a topology and do everything for you, so you don't have to rely on any specific controller for a lower level. And also you can take it even one step further and separate even the hardware and the OS on the box. If we look at layer 2, layer 3 on switches, we've seen white boxes for quite some times. It's not been that well deployed and it's not been mature on layer 0 or layer 1 yet. We start to see initiatives today going and pushing for those kind of technologies. So I'll show you an example here in a couple of slides. And if we look at the typical deployment scenarios today, as I mentioned before, it was driven primarily from the cloud providers to start with. And if we look to see what they have deployed today, I made a very simple network drawing here. But in general, it's been commonly deployed to use an open line system from one vendor. That open line system can be completely separate from the rest of the equipment. Then on top of that, you will run your services. Either you will do the Microsoft approach, if we look at the cloud providers, and run your DWM optics embedded directly into the switches and routers. So they use tons of PAM4 DWM optics, run that over their Azure cloud networks. Or you can do it through transponders, where you have standardized client interfaces, gray interfaces, and use a transponder to run that. But what's commonly used here in this case now is that those things are coming from different vendors, but they are controlled via what I call here a self-developed open network controller. So since there has not been an open controller to use, they've developed their own controllers that fulfill the kind of the open approach to it. And this part now has, of course, generated in multiple different initiatives on the market with different initiatives, and also with different projects within these initiatives to try to standardize around different both hardware and software features. I've selected a couple of those initiatives and also a couple of projects that I think is interesting and that I also think is having a lot of traction right now, where there's a good collaboration between both vendors and operators. And so I selected the Open ROADM project. The Open ROADM project was initiated by AT&T, where they wanted to have a ROADM model that they can deploy in a standardized way. That particular initiative have a very, very strict specification on hardware. So it specify exactly what kind of output power the amplifier should have, exactly what kind of feature set that box should have. For me personally, I think that's a huge disadvantage, because that means you will have a box with a particular feature set that could be optimized for long haul, but might not be optimized for metro or metro access networks. But that's what the Open ROADM initiative is doing. They do have a lot of members both from the vendor side and also from the operators. But one of the major initiatives that they are doing that seems to be the big focus area of the controller side is the transport PSE. The transport PSE is the kind of the gray part there within the black piece. So if we look at it on the overall side, from the top we have some kind of either an orchestrator or a higher level controller, application layer, talking to the transport PSE through standardized interfaces. Typically it's REST interfaces northbound. In that controller, you have a service handler that will handle the communication between the higher or the orchestrator and the controller. Then you have a path competition engine. That path competition engine is computing the best route through a network. It can be based on a number of hops. It can be based on the best shortest distance. And in the future, they will also be adding support for optical parameters there as the factors to design or dedicate the best path to the network. For example, then using OSNR performance to select the best route in the network. And then you have the topology manager. The topology manager build up the topology of the network by using LLDP, and from there build a topology, network topology showing what the network looks like. You have a renderer in there that is handling the optical component setting, so it configures the optical network, the route through the network, and so on. And then, last but not least, you have the OLM. The OLM is controlling in real time your optical power level, doing all the power balancing and so on in the network. So those are the different modules within Transport PC. Southband, they talk directly to the network elements via netconf interfaces. Within the network element, the data should be stored in Young models, so that's the modulation format for it, or the data model for it. It can also talk sideways directly into the path competition engine through different type of, for example, simulation tools, planning tools. I'll come back to that when I go through the next initiative here in a second. So that part is heavily developed, and it's a lot of things going on there. It seems to be the one that more and more of the different initiatives relate to as part of their open approach. So that's an interesting project. You can find a lot of information on it on the web, what it means and what kind of initiative and the roadmap for it. Another interesting open initiative is around the Telecom Infra project, TIP. TIP was originally driven by Facebook, and it's also now a consortium of different vendors and operators. TIP itself have different groups. One of the focus groups that I'm talking about here is the one focusing on open optical and packet transport. They have other groups as well. But within that group, they also have, whatever you call it, subgroups or a dedicated group for certain tasks. And a couple of those initiatives that they have in there are those two that I mentioned here are two examples. Apollo is one of the first that I've seen, at least on the market, the full approach to a full, I call it a white box for layer 1. So this box now is designed in a way where it's supposed to have a generic chassis that can house 3 sleds. That project specifies the exact dimension and functionality of those sleds. So the idea here is that you can buy the chassis from vendor A, but then you can buy the sledding units from different vendors with the appropriate technology that you select. In those modules, you have 400 gig interfaces and a couple of CP2s for 400ZR. So that's the line interface here will also use the 400ZR, which is another interesting open approach to this technology. And that box now is, there's a lot of attention around it. It's a lot of focus going into it, and it's very much driven from the operators in this case because they see a demand for such a box, or such a muxponder or transponder, or whatever you call it. Another interesting project with the TIP is the GMPI. GMPI is a simulation tool. That simulation tool is a multi-vendor simulation tool that uses the optical component information and actually simulate the network performance across multi-vendor environments. This one is proven out to be working very, very well. If you compare it, if you run a network with vendor A in one segment, vendor B in one segment, you use their dedicated design tools and simulate the network, and then you combine that, and you compare it with the result of the GMPI. The result is very, very similar. So it seems to be working very well, and that's something I personally find very, very compelling, to have a generic and open controller that can control multiple different vendors in one go. It will make optical interop so much easier. This part will also have a planning tool, and it can be run both offline, so you can do your offline planning, but it can also be combined and connected into the transport PSE, which means then you can in real time simulate your network performance, so you can set up a network link, and then from there simulate the optical performance and make sure that you can guarantee a certain bit rate, baud rate, distance, or spectrum efficiency through your network. But there are a lot of other interesting initiatives going on around TIP as well. You can find information on their homepage as well. So that was the session I had around disaggregation. And then if we look at the trends in optical networks, because that's something that we are heavily, embedded optics, that's something that we get a lot of engagement around, because we see a strong trend of going toward running your DWM optics directly in your host equipment over an open line system. Maybe not so much for long distance network, but for metro and access applications and data centers, that's certainly something that's a strong trend. There are some challenges with it. So if we look at some of those new kind of optical components that is about to come out here or has recently been released, 25 gig is getting market share and traction, especially around the mobile fronthaul application. It comes with some challenges, but it's a SAP28 form factor optics that can also be used for 25 gig Ethernet that you have on many of your switch or host equipment today. You also have 32 gig fiber channel. Also comes in SFP28. Both Cisco and Brocade have now on their latest SON equipment released 32 gig DWM as part of their portfolio. So that means there is a need to transport those as well. Then we have the 100 gig PAM4. This is something that we have been working with quite a bit, and we've seen a lot of traction around. There was an announcement yesterday that they've been sold now and deployed in over 100,000 units. It's primarily driven by Microsoft that's been doing a lot of deployments with 100 gig PAM4 directly in an embedded environment. So it's a kind of a little bit awkward beast there, those 100 gig PAM4, consisting of two peaks with 25 gig each, PAM4 modulated, so it's 25 gigabaud and 50 gigabit per peak that you can fit into 100 gigahertz spaced window in your line system. And then last but not least, another initiative that is gaining a lot of traction right now is the 400ZR. It's the 400ZR is standardized via OIF. 400ZR Plus is not standardized yet. Not sure if it will be, but there are initiatives working on that. But that's something that I would say all the bigger cloud providers will move over to, and I think they pretty much all will move over to running those in an embedded approach as well, once those are out and available. There are, however, some challenges with all of those. They come in general with fairly low output power, and this is because if you run them embedded, you have power constraints, so you need to have, you cannot maybe have micro amplifiers in your transceiver, so it will come out, and it's often silicon photonics, which by nature typically have lower output power. They do require high OSNR. That actually goes across all of those. And they have limitations in their dispersion tolerance. So that means in order to handle those, especially in a mixed and open format, you need to have a line system that's been taking this into consideration from day one. And if I just did a slide here showing some of the requirements that we see from our customers asking questions around it, that an open line system should of course be open for anything. It should be, you should be allowed to run your optics directly in a switch or router, the embedded approach. You should be able to have a transponder from a vendor, from any vendor running over it. So you should be agnostic to what the host equipment and the transponder looks like. You should have a client set up where you can actually determine what kind of traffic comes in and balance that in an appropriate way, so you get a complete zero-touch provisioning feeling of it. And last but not least, on the line side, you should be able to get an automation there, so you actually take care of those especially dispersion-related issues or challenges that you have with a newer format. And that means that you have a tunable dispersion compensation unit that will automatically tune your network to the appropriate levels and so on. And I think I'm pretty spot on time, right? So thank you.